Pan sample number 2 of soil that we have to examine here today is a soil which obviously contains a much higher amount of clay. This is evident when we first pick up one of the PEDs which has been formed in this soil. This particular one was formed by a person who was determining the textural class of this soil. Now you noticed in the last one, when I got ready to exert a force on that particular PED or soil structural unit, that it broke rather easily. Now in this particular case, if I take this one and exert the same force, no matter how much force I exert, I cannot get this particular one to break. Matter of fact, this one you have to use both hands and push on it really hard to get it to break. So this is an indication to me that this particular soil has a much higher clay content, because clay is kind of the binder in this soil which helps hold these aggregates or clods together. So to repeat the procedure that I did on the first sample, I will take approximately 25 grams of soil again. Now there will be some small PEDs or aggregates in the soil. If you cannot get this to moisten and form into a ball, then we may have to use some method of breaking these aggregates or PEDs down, crushing that. And in the laboratory we use a mortar and a pestle, and I'll demonstrate that on a later soil sample. So I'm going to start with my palm full of soil. This one will not take water nearly as rapidly as what the previous one did, and it will actually absorb more water than the previous much coarser textured soil did. You'll notice that I've added about the same amount of water to this sample as I did the previous one, and it only wet down to a much smaller amount. This soil will feel much more moldable. It will also be much stickier. You notice how it's sticking to my fingers and the palm of my hand. The aggregates that are in there have become moistened now, and what I'm doing is I'm molding those into part of my ball. Notice how it stains my hand, whereas the other one did, and that's also indicative of a much higher clay content. So once I've formed this ball, I can follow through my flow diagram. Does it remain in a ball when squeezed? Very much so. That moves me down the flow diagram to where I can begin my ribboning exercise. This soil, I would expect, based upon the way it's performing in my hand right now, would form a very strong ribbon. The clay content is high enough to where it wants to stick to my fingers to the point to where it actually becomes hard to ribbon because of that. But as I squeeze this out between my thumb and forefinger, notice how it doesn't break off. It wants to remain together. There, it finally broke. When we're talking about the number of centimeters in length that this became, we have to do an estimate here, but it says, does the soil make a weak ribbon less than 2.5 centimeters? 2.5 centimeters is approximately an inch. This soil ribboned to a much greater extent than that. Does the soil form a medium ribbon from 2.5 to 5 centimeters long before breaking? I would say this particular soil is in that range. We could get it out there somewhere between 1 and 2 inches prior to the time that it would break off. There's a ribbon of approximately 2 inches in length. So we're kind of on the borderline here between the 2.5 or between the under 5 centimeters and over 5 centimeters. So we're going to say for the purpose of this example that this ribboned out to a length of approximately 5 centimeters. Now, the next procedure tells us, based upon the ribboning length that we're in, if we follow down the flow diagram, we have a choice now between a soil that is going to be a sandy clay loam, a silty clay loam, or a clay loam. So the next procedure is telling us to take a small amount or pinch of this soil. I don't really need to take it in this case. It says put it in the palm of your hand and get it excessively wet. Well, I have more than enough soil left in the palm of my hand here to perform this next procedure. So I'm going to take and add water to the soil that's remaining in the palm of my hand. Now what I'm doing here is to determine the amount of grittiness or smoothness that's in this soil. I'm rubbing this soil sample. I've got it excessively wet, and I'm trying with the tip of my finger to determine how much grittiness versus smoothness or slickness there is in this sample. It says, does the soil feel very gritty? Well, that's a no. There's not very much grit in this particular sample. So it is not a sandy clay loam. Next step says, does the soil feel very smooth? There is a considerable amount of smoothness here. And the last one says, neither grittiness nor smoothness predominates. Well, this soil, and here again, when we're doing soil texture by feel, it is not an exact science, it is an estimate. This soil, based upon this procedure, comes out as either a silty clay loam or a clay loam. Now, people that have had a considerable amount of experience at doing this would feel more comfortable as placing this into one of those categories or the other. If we really needed to know the exact texture of that soil, we would probably take this soil sample into a lab and we would perform a textural analysis, which is something we will be doing in a later lab in this particular course. So for the purpose of today, we're going to classify this soil as either a silty clay loam or a clay loam. When we determine the textural class on this in a later lab, we will get the exact percentages of sand, silt, and clay, take these to our textural triangle, and that will determine whether this soil is a silty clay loam or a clay loam.